Hi, my name is Jason, and I'll be giving a presentation on my FY project with the title Development of Decentralized Application Using Blockchain Technology to Improve Healthcare and Medical Record Systems in Malaysia.
So we're going to first start by talking about some core concepts of Ethereum, blockchain, and Web3.
Which is, we'll look at the Ethereum blockchain overview. A blockchain is stored on many different computers. So this is the visualization of it. This is the blockchain network, which is the network we are going to use. So if you want to interact with this network, we will have to use Web3.js to code everything and then interact using Web3.js. And for the normal users, they have to use MetaMask to interact with this application and also with the blockchain. Here are some details about smart contract, where we create the smart contract, we type out the code, and then we have to compile it in a Solidity compiler. It will compile into two things, which is the ABI and also the contract bytecode. So the ABI is what we'll use to interact with in our backend code. And all our backend code is in JavaScript. And remember, this smart contract is it's programmed in a new language, which is called Solidity. And Solidity has no way to interact with JavaScript. So we have to compile it and then make it into an ABI. Then JavaScript can only understand this. And so we can create a backend code this way. And the next one is the contract bytecode, which will be deployed to the network. Remember we said we're going to deploy to the Ethereum network. Rinkeby is actually a Ethereum test network. So we're going to use a test network instead of the real network where we have to pay real money. And this one, we don't have to pay real money, but it's essentially the same as deploying to the actual network.
As I've mentioned just now, Web3 is essentially our portal to the blockchain. And Web3 will produce an instance, which is here, depicted as this symbol thing. And Web3 needs a provider, where the provider serves the purpose of telling the Web3 instance which account the user is using and also which blockchain is the user connected to. And in this case, our blockchain is the Rinkeby network, and the account mnemonic stands for the MetaMask account private key. And we'll need to provide these two, the account mnemonic and also the Infura API. So the Infura API is provided when we go to the Infura website and sign up, and it will essentially let us connect to a node that is created by Infura. And not to get too detailed, the Infura is essentially just there to help us connect to the Rinkeby network. And we'll need these two details, the Infura API and also the account mnemonic, to store in the provider, and then only we can access into Web3. And now I will go into the code explanation. So now let's talk about the smart contract code. Here is Remix IDE, where I initially write the code and then test out certain features of the smart contract. So whenever I want to add new functions or features to the smart contract, I always come back here. Firstly, write the code in Remix. And then why do I do this? It's because Remix makes it very easy to compile and then deploy the smart contract or just through Remix. It's very simple. So let me demonstrate it here. I can just click compile and I can just click deploy, and here, that's it. And I can directly test the code. If you want to test the code in actual deployment, it will take much more. I have to write a few more different codes, and then there's a lot of things that are going on that I will show you later. But for Remix, that's it. I just need to write the smart contract and then just click compile, just click deploy, and that's it. I can show you test the smart contract. Plain and simple. So here, I can test out this feature function, and it shows that it is working successfully. It shows a tick. If it's not working successfully, it will show the error code, and then I can start debugging here. So I can also test another function, and yep, it's also working. It says call, and then here's the output that I've called. So yeah, we can see that it's working perfectly fine. So after writing the code, the smart contract code here, I will go to the Visual Studio Code and then check out the Ethereum folder. So I'll explain each item inside the Ethereum folder one by one because it's all very important to understanding the blockchain system code. So here, whenever I update something, add new features inside the smart contract, I will test out here first, remember I said, and then I will copy this code, the latest code, and then paste it here. And after that, I will have to go to the compile script. The compile script, as I have already mentioned just now, that this compile script is this part here, where this is the smart contract. It will need to compile the solidity contract to an ABI and also a contract bytecode. And ABI is needed for us to use JavaScript to interact with the smart contract. Otherwise, there's no point creating that this blockchain medical record system won't exist. Let's just put it that way. So yeah, this compile script will compile the smart contract which is here, and then it will turn it into an ABI and also a bytecode. And so then we'll check out the deploy script. So the deploy script, as mentioned just now, the provider needs a mnemonic and also Infura API, as it is shown here, the account mnemonic and also the Infura API. And both these values are needed inside the provider. Then it will provide into the Web3 instance to let Web3 know which account we are using and also which blockchain network we are using, which in this case is Rinkeby. So yeah, these are the two things provided here, and then put inside the provider. Then we put this provider inside the Web3 instance, and then we'll deploy it to the Rinkeby blockchain. So let's show how it's done. I will cd Ethereum, go to the Ethereum folder, and then node, we'll need to compile first. So yep, it's running the compile script. And then yep, it will run the compile script, and there we go. This is the ABI, which is how JavaScript understands the smart contract and it will interact with it. But yeah, it's not readable by humans. It's how JavaScript understands the smart contract. And so the command tree is working fine. You can just ignore this error. It's definitely working fine. And then we will click node, we'll type node deploy.js to deploy this smart contract. But I've already deployed it, so I'm just doing this for demonstration purpose. And it will show that it's deploying. It will deploy this smart contract as I've shown just now. It will deploy this smart contract to the Rinkeby blockchain, the contract bytecode. And it's taking some time as it is deploying to the real blockchain, and miners have to validate this transaction and add this block to the blockchain. So yeah, there's waiting time. So after getting it will say the contract is deployed to this address, and we can paste this address into here, which tells Web3 where is our record, where is our smart contract, and we'll paste it in. But I've already created it, so I won't do this. And after that, Web3, this is how we create the Web3 and the Web3 instance. So yeah, and that's everything for the Ethereum folder. Oh yeah, and before actually deploying the code to the actual blockchain, the Rinkeby blockchain, I will write another test using this Mocha test framework, and it is tested using Ganache, the Ganache blockchain, where I can write the code to test out certain features like can add record, it can retrieve all record address. Yeah, I'll test out each feature, and then how do I test it? I'll write npm run test and then click enter, and it'll run each test automatically. So yeah, why do I need to do this many tests? Like in Remix, I've already tested a smart contract once, and I've done it again using the Mocha test framework here. Why do I do this? It's because blockchain systems all use real money, and there are dire consequences if the smart contract has errors where malicious users can exploit the smart contract for their own financial gain, where they can hack users' funds and all that. So it's very important to ensure that the smart contract is error-free and safe as possible. So I've tested it twice to ensure that there's no errors and it's completely bug free. So yeah, here's the code. Here's how I run the code, and then it will show this tick, which means that the features are running successfully. Records can deploy, record contract can add record. Yeah, all these features are running successfully. When it doesn't run successfully, it will show an error, and I'll have to then debug. But in this case, it's showing all successful. It's all 7 of the code is passing. Then I can proceed to go to here and then click npm run start to start up the node server.js, which it will start the system. I can then go to localhost to access the system, and it's loading. Okay, so now let us copy the record address, and there's something we can do later, and let's paste it in first. So this is our the address of our smart contract. So yeah, we can see that we have deployed the smart contract. So okay, now here is our home page. So what do we need to do when we first reach here? We have to log in to the MetaMask. And just now I've already logged in, so now I'll show demonstrating logging in again. Whenever you go to a new blockchain system or any other blockchain system, you will have to log in and then log into a MetaMask, as MetaMask is the portal to interact with any blockchain applications. We'll need MetaMask for any blockchain applications. So yeah, here's the home page. There's nothing special. It's pretty much just a generic landing page. So you'll have to first create a patient account. Let's make sure I'm selected as a patient. So yep, I am selected as patient, and let's go to register patient. So this is the based on the assumption that the patient, joined, have just wanted to create a new medical record on this system. So yeah, here I will speed up me typing the details. Okay, so here I've done typing out the details, and now I'll click create. And what will pop up is a MetaMask transaction. And what is this MetaMask transaction message? So it will say how much gas is needed to include these details into the blockchain. And it will say here how much fees do I have to pay. And when I click confirm, it will start to load, and it will add these records into the blockchain. There is a wait time for this. So I'll click confirm. And now this wait time is where the details are adding into the blockchain, and we need to look for miners to mine the block to include this information into the blockchain. So yeah, it will say account created successfully when I'm done, when the adding of the record to the blockchain is done. So yeah, done. Now I can come here to the record list, and then it will show a list of the medical records that have been created. So this is my address, and you only show the address here, as this as essentially protects the user and allows for anonymity, where the hospital and doctors won't be allowed to see the any details of the user unless given permission. So use as a patient, this is my own medical record. I can click view record to view my details. But before I do that, I can go to Etherscan, which is a blockchain explorer. I can see whenever I've created whenever I store new details into the blockchain. So yeah, you can see I've created this 1 minute ago, which is the record details. Just now I stored my record details, and I can click here to view some details of the transaction. Yeah, you can see this is my Ethereum address, which is correct, F697. Yep, F697 is the exact one, and I've stored my details into the into the smart contract, the blockchain, and this is the transaction fee. So, right, remember I said no doctor and hospitals can view records of the patient. Yeah, even through here, you might think, well, maybe the doctors and hospitals can check the user's details through here, right? No, not at all. You can see here that there is absolutely gibberish. So this is the input data that we stored just now, and it has been hashed. So this is the hash where it's just random gibberish that cannot be read by humans. So yeah, there's no way any other people that are unauthorized can access the patient's data. So now I'm logged in as a patient, right? Now I can click view record. So, and you load, it will actually, behind the scenes, it will retrieve the medical record from the blockchain and then displaying out here. Yeah, so here, okay, now it's loaded. Yeah, these details are retrieved from the blockchain and then displayed here. Notice that just now when we store medical records into the blockchain, there is a transaction popping out, remember? And I need to click confirm. And now there isn't. Why is that? So retrieving data from blockchain does not require a transaction and it does not require gas fees. That's the design of Ethereum. That's the design of this blockchain. Only when we are storing records, we need to wait and we need to pay for gas fees to store our record into the blockchain. When we retrieve it, we do not have to pay, and there is essentially no wait time. We can instantly retrieve the data. So yeah, here are the data retrieved. Just now we stored these details. And here, yep, the emergency contact, the personal details. And the appointment is currently empty as I have not created an appointment yet. And yeah, that's it for the patient profile. And there's one more place where we can view the patient's profile is through view profile. Here, patient view profile. I can check my own profile here. So yeah, and now we'll test out the edit profile feature. For the edit profile, let's say I want to make some changes, like maybe I type my name wrongly or my phone number wrongly. Yeah, this edit feature is not built into blockchain. Yeah, it's actually impossible to do, but due to a clever trick that I've thought of, I've managed to make implement this feature as through my objective. I aimed to create a system that is very user friendly and also an enhanced user experience. So yeah, an edit feature is very important. And let's say I want to change my medications. Maybe I'm taking new medications, paracetamol. Okay, so I can just click edit, and remember we're storing new records in the blockchain. We'll need to click this transaction again. So yeah, let's click confirm, and later we'll see what's going on here. I'll demonstrate this neat little feature through this Etherscan. So let's wait. Okay, so the transaction is created successfully, and we can then see that, remember I've changed the medication. Let's see if it has been changed. So yeah, see, it changed to paracetamol. Just now it wasn't paracetamol and now it's changed. So let's refresh Etherscan, and okay, we'll see blockchain. So now I'll explain what's going on. So blockchain is immutable in nature, where every record, every block in the chain cannot be replaced and cannot be altered. So as you can see here, just now this is the one where we stored the details for the first time, and this is where we created a new block to replace the previous block's data. Remember, I said that it's immutable. You cannot change anything in the blockchain. See, it's not actually changing it. It's creating a new extra block, and then I'm typing in the same details and making change to only one field, and it changes it inside, and it replaces it inside the blockchain. So yeah, here's how it's done. Right. So next, let's say we'll log in as a doctor, and we can then click register doctor. So yep, I'm gonna fast forward this as well. Okay, so I click create, and yep, as we are again storing records into the blockchain, we will need to undergo this transaction again. So we need to click confirm, and the same thing happens again. We'll need to wait. Right, so here the doctor has been created. We'll click OK, and now we can view the doctor's profile, which is here. I'll click view profile, and here we can view the profile of the doctor. These are the details of the doctor that we have just typed in, and here they display a picture of a doctor. And this picture will be according to the gender. If the gender is a male, it will put a male doctor picture, and if it's female, it will put a female doctor picture. Yeah, and that's that. So now there's a doctor and a patient. Now we can test the other features out. So let's say we have we want to view the records of the patient without permission, right? I haven't done any granting any permission to the doctors yet. And now I'm a doctor. I want to view the record of this patient. Let's try and see. I click view record. It says you don't have permission to view this account. And yeah, there's completely no way to view the patient's account without permission. No matter how I click, and even checking through Etherscan, it won't show. So yeah, this is completely foolproof. There's no way you can check this. And this security is ensured by the smart contract. So yeah, now if I want to view the patient's medical record, I have to go to the patient and click allow access. So this feature is very important as it grants the patient full control of their own data. It is completely secure, and it gives patient the ability to only grant doctors, another patient, or even the hospital access only with the patient's permission. So I forgot to grab the doctor's address. So yeah, I need the doctor's address. So I'll click copy. And yeah, I can paste the doctor's Ethereum address here and then click approve. And it has to go through this transaction again because it's allowing the permission, it's storing this doctor's address into the permission. It's an array inside a smart contract, and whenever this address is inside the array, then the doctor is approved. Otherwise the doctor cannot access. So yeah, there's again a waiting process. And yeah, so permission has been granted successfully. Okay, so now the doctor has been granted the permission. Now I can then use the doctor's account and then click view record. So yeah, now I can view the patient's record without an issue. So now, since there's already a doctor and a patient, but there's no appointment yet, the doctor has yet to create an appointment. So now imagine, yeah, so the patient has just granted permission to the doctor. Maybe the patient has just visited a hospital, and the doctor asked to grant access to the patient. So grant the patient asked the doctor asked the patient to grant access to himself, to herself, so that she can make an appointment. So now let's say the patient has already registered, right? and has already granted permission to the doctor. Let's say the patient just joined this hospital, and now the doctor has been granted permission. The doctor wants to make an appointment with the patient. So he'll click make appointment, and let me ensure that, yep, I'm logged in as the doctor. So yeah, I need the patient's Ethereum address. Okay, so I'll get the patient's Ethereum address from here, and then go here, and I'll paste the patient's Ethereum address. I will type the date of the appointment, and I'll speed this up again. Okay, so done. Here are the details of the appointment, and this is the patient that I want to make appointment with. I'll click create, and it will load again as I am storing this appointment details into the blockchain, hence this transaction. Okay, so the appointment has been created successfully. And then click OK. And now, now that I've created successfully, I can then check. Remember, now I'm the doctor. I can then check on this patient's profile. Here, there is the appointment details. It was empty before. Now it has been displayed. So yeah, here are the details of the appointment. And as a patient, there is no way you can view the doctor's profile because you have, yeah, I didn't implement this feature because this is to ensure the safety of the doctor. Let's say maybe patients want to misuse this power where they can view the doctor's private information. And so, yeah, there is no way to view any doctor's profile. So the only way I can view which doctor is through here. I can view the doctor's name. So maybe when I go to the hospital, I will show them my medical record and then tell them I have an appointment with the doctor, and then what's the date and time. Maybe not show them the medical record, just tell them the date and the time. And then yeah, I can then proceed to the appointment with just these details. And this ensures not only the safety of the doctor, it also ensures the safety of the patient, where both patient and the doctor have equal rights to their own data. So after that, I can click dashboard. And this dashboard is there for both patients and the doctor to view, as data should be shared between all the users of this system, where unlike most systems, the users are usually exploited and data is usually collected without the user's permission and then exploited for monetary gains. But in this case, this data is shared among all users. So this data is especially important for hospitals that want to emphasize on the growth of their corporation, their company. So here they can view the month-over-month patient growth and the month-over-month appointment growth to maybe optimize strategies to acquire new patients and also increase their appointment count. So here, just now it was 0 for some, and now it's all 1 already because there was 1 patient registered, another doctor, 1 appointment, and also granted 1 time permission. So here you can see there is doctor and patient. There's only 1 of each, and both are created in May, as we can in April. As we can see the date here, it's April this month. So yeah, it's April. There is 1 appointment in April here, and we can see the number of appointments per patient through this pie chart. It says which patient and how many appointments they have created. Since there's only 1 patient, so this pie chart is only fully distributed by this patient, so 100%. Right, so this is the dashboard. And now let's say let's say the patient has finished the visit, and the doctor wants to update the appointment status to completed. Let's go to the update appointment. So now I'll fill in the details, and let's say the status is already complete. So yeah, just now I've made a mistake. I shouldn't have filled for make appointment. I shouldn't have filled in the prescription diagnosis and notes, as the appointment hasn't the patient hasn't undergo the appointment yet. So the doctor hasn't even prescribed and diagnosed yet. So yeah, those should be empty when making appointment. Only this appointment information should be filled up and not this medical information. The doctor will prescribe the medication and diagnose after the appointment is complete. So notes, and these are the notes, and then click create. So yep, and we'll see. Now we can go and see that the status has been updated to completed. So yeah, here we can see, and these are the details of the appointment. It will be stored here in the patient's profile, or you can call this the medical record, and it will show here complete and the prescription and all that. So yeah, now, and I'll take some time to create another patient to demonstrate the dashboard. So I'll be right back. Okay, so I'm done creating the new patient, and I've also created an appointment for this patient as well. So yep, I'm now logged in as this patient. It's called patient 2, and it's a female, and here are her details that I've just created. And there is an appointment already created where the doctor is still Olivia, and the date and time is different, and the status is pending. So now you can check the dashboard and see. Yep, so now we can see that the month-over-month patient growth is 200%, as there are 2 patients currently, and there are no patients in March, so it's 200% growth from last month. So yeah, and we can see from here, this pie chart has changed shape. So number of appointments per patient, half is one appointment is by the first patient, and the other appointment is by the patient I just created. So now they are equal weightage of 50%. As you can see, it will show the patient's address in the center, and yeah, and the appointments here. So this analytics doesn't compromise the user's data, but yet it still provides enough value to the hospital that they can make business plans with. So yeah, this is very valuable information for the growth of the hospital, the company in general. So there's also this neat little feature where patients can revoke access that was given to the doctor. So now the doctor can remember, just now the doctor has access to the first patient's records, and yeah, he still has access. Now let's say the patient wants to revoke this access. Let's say the patient has already visited the hospital and is now planning to leave, and he wants to gain back his own rights to his own medical records. So he can click revoke access, type in the doctor's address, and then click revoke. Then after this, the doctor no longer has access to the patient's records. This maintains the rights of the medical records back to the patient. So yeah, it has been revoked successfully. So this feature is especially useful when the patient wants to leave the hospital already and no longer wants the doctor or the hospital to misuse the patient's data. So now the doctor has signed in, and then try clicking on the medical record. It says you don't have permission to view this account. Before this, it was available, and now it's no longer available. So the patient can leave the hospital without his medical record being compromised or being scared of the hospital misusing this data. So now I'm going to talk about the possible scenarios. So firstly is the scenario where the patient is in a coma and got sent to the hospital through an ambulance, and he has yet to register in the blockchain medical record system. how do we solve this issue? So the patient's family members can use the patient's mobile phone to access this system and register for an account. I have successfully published this mobile application through the Wurzel, and so now I can access this application anywhere, even on my mobile phone. This is my mobile phone connected. I can click browser and then paste in the link to the Wurzel app. But there is this known issue in Wurzel where, and it has not been fixed, where Wurzel apps and Wurzel blockchain apps doesn't work. So yeah, in this case, I can look at stuff, but I can't create medical records and all that. So this is a known Wurzel issue with blockchain. So I hopefully in the future there will be a fix to this. But yeah, so this is how the page currently looks on mobile. And so yeah, when the patient is in a coma, the family member will then grant access to patients on their behalf, grant the access to the doctors and the hospitals on the patient's behalf. So yeah, and the next scenario is where hospital franchise use the same blockchain, where let's say Pantai Hospital all around Malaysia, Singapore, Indonesia all use the same blockchain, and they can all use this medical record system without compromising their security and run their day-to-day operations successfully. And the next case is where hospitals in Malaysia all using the same blockchain. So this scenario is where the government says that only whole Malaysia needs to use one blockchain, regardless of the franchise of the hospital. So the system can also accommodate for this scenario as when all patients around Malaysia stores their record on the blockchain through this system, doctors can only see their own profile and not other doctors. All the medical records for all hospitals in Malaysia will be displayed at the record list page, and the search feature will ease the doctor in searching for the records. And the doctor can only view records only if given access by patients. So it's completely secure. And now we're going to talk about the recommendations and future work. So for the user interface, it is somewhat simple design. It is somewhat simple in nature due to the technology limitations, and only a limited number of front-end frameworks work with blockchain systems currently. So in the future, hope that more front-end frameworks can accommodate for blockchain systems. That will ease the designing of the user interface and make it more interactive and more attractive. And next, storing of documents in medical record. So the current system that I've designed does not allow for the storing of images and PDF files in the medical record. To implement this feature, IPFS technology needs to be used, and I didn't spend time to explore this feature as I focus on other parts of the system. And lastly, for the payment feature, I did not implement a payment feature as that is a hospital system feature, but I'm currently doing a medical record system. And also, a payment feature would be too complex, consisting of printing and storing invoices, plan for the payment of each treatment, calculate the charges of each treatment, and the method of storing these details in the blockchain and more. So there are a lot of issues to consider for a payment feature, and I didn't include. And hopefully in the future, they could researchers can include this feature into a new blockchain medical record system. So yeah, that's it for my presentation. Thank you.